So in this video we're going to have a look at some arithmetic and geometric sequences. Now we previously looked at arithmetic sequences in one of our other playlists, and an arithmetic sequence is where you're either adding on or subtracting by a fixed amount each time. Well, a geometric sequence is if you are multiplying from each term to the next or dividing, but really we're going to treat it always as a multiplication because you can rewrite a division as a multiplication. So for our first sequence then, part A says write down the next two terms for each of the following sequences. So we have 2, 5, 8, 11. What's happening each time? Well, we're adding on 3. So our next two terms would be 14 and then 17. Moving to sequence 2 then, we have 2, 4, 8, 16. What's happening each time? Well, we're multiplying by 2. 16 times 2 is 32, and 32 times 2 is 64. For the third sequence, we have 13, 10, 7, 4. What's happening this time? Well, we're subtracting 3 each time. So 4 minus 3 is 1, and 1 minus 3 is minus 2. For the fourth sequence, we have 600, 300, 150, and then 75. So each time here we're dividing by 2, which is the same as multiplying by a half, and that will become important shortly. But if we're dividing by 2 each time, 75 divided by 2 gets us 37.5. 37.5 divided by 2, 18.75. Obviously you'd be fine to write those as fractions, but decimals are quite nice for this particular problem. So we've got our next two terms for each of the sequences. Part B says to determine, hence determine, if the sequences are arithmetic or geometric. So that comes back to our definition of the type of sequences. So for our first sequence, because we are adding each time, that makes this an arithmetic sequence. So it's an arithmetic sequence. For the second sequence, we're going 2 times 2 is 4, times 2 is 8, times 2 is 16, and so on. So because we are multiplying each time, this makes it a geometric sequence. For the third one, which is 13, 10, 7, 4, and so on, each time we are subtracting 3, and if it's a subtraction, this makes it an arithmetic sequence. And for the last one, 600, 300, 150, 75. So we're dividing by 2 each time, or, as I said, importantly, timesing by a half. So because there is a multiplication there, or a division, depending on which way you want to view it, that makes this a geometric. So this is a geometric sequence. So part C says for any geometric sequence, state the value of the common ratio R. Well, the first one is an arithmetic, so we can say that's not applicable, and the same for the third one, because they're both arithmetic, and we've already discussed for this one we're adding 3 each time, this one we're subtracting 3 each time. For our geometric, the common ratio is really the multiplication factor. Now, we've already discussed what they are, but actually, the way that we can work out what it is we can take the second term and divide it by the first term. So for the second sequence, we can do 4 divided by 2, which gets us 2. And basically, we're looking for this multiplication. So there's a few ways we can find it. We can either do a division of the second term by the first term, or possibly the third term by the second term, and so on. As long as you have a gap of a single term there, you can work out what the R factor is, the common ratio. Or if you have the sequence, you can just work out what the multiplication factor is. Similar then for the fourth one. Well, we know we're dividing by 2, but as we've said, really that's a multiplication of a half. So that's going to be our important one. But in a similar idea as how we found it for the second one, we can take our second term, which is 300, divided by the first term, which is 600, which simplifies to that factor of a half. Okay, So whenever it's the common ratio, even if you are really dividing, we really write that as a multiplication, okay? And that's how we can show for these whether they are arithmetic, geometric, and if they're geometric, what the common ratios are.